Hey, hi guys. Can you please confirm I'm audible? Just let me know once in a chat so that we can start our session. Yes, no?
Yes, sir.
Okay, fine. Thank you. So let me share my screen. After that, we can start. Okay, fine. So today we are going to start with the LSTM. Let me open my pen as well. Okay, fine. So is it visible, everyone? Can you please confirm?
No, sir, it is invisible.
Now, can you please confirm once?
Yes, sir.
Okay, fine. So we are going to start with the LSTM, long short term memory. Long short term memory. This is the full form that we have for the LSTM. But before this one, let's try to understand first of all why LSTM is important. Why we need LSTM? So when we learn neural network, that is called NN, okay, neural network. So in a neural network, we can't remember our data. Our neural network, it can't remember our data, whatever the data that we are going to pass. So if I create one simple architecture, so let's say this is the simple architecture that we have for the neural network. Like here, we have the data. This is the data that we have. Okay. Here we are going to pass some data like x1, x2, and this is x3. Three data that we are going to pass. Now here we have the hidden layer. So we are going to create the hidden layer here. So we are going to pass some data here. Okay. Now after that, we are getting the final as a output layer here. So this is called a output layer. This is called input layer, and this is called here the our hidden layer. Okay. So what happened in a neural network, in a simple neural network, when we pass a data, our x1, x2, x3, it will get multiplied with the weight, and based upon the multiplication that we can add the biases, and at the end that we are getting some output. Like if we are going to send the cat images, we are getting the cat image, or we are getting the dog image. If we are getting the dog image, we do the backward propagation where we update the weights. Okay. Now, as we know, neural network can't remember our data, whatever the information that we are going to pass, whatever the features that we are going to pass. So that's why we got here RNN, that is called recurrent neural network. Now, what happened again in a neural network, as for the last discussion, in a neural network that we have the two issue. The first one is vanishing gradient issue. Second one is, if I show you, so let me open my file here. So this is our neural network file. And here in this particular file, in our last session, we discussed we have the two issues here. First one is exploding gradient issue, and second one is vanishing gradient issue. But how we can resolve this particular issue? So exploding gradient issue, we can resolve with identity initialization, backward propagation, and gradient capping. Second, that we have vanishing gradient issue. So we can solve with weight initialization. We can choose the right activation function, or we can use the LSTM. Okay, so to solve this particular vanishing gradient and exploding gradient issue, we are going to use here the LSTM, that is called long short term memory. Okay, now let's try to understand what is this long short term memory. So what happened? As in a RNN, whenever we are going to pass a data, and based upon the data that we are getting the prediction, let's say if we are going to pass a data that is called HELLO, and we are getting the final prediction that is called O, output, hello, output. Right. Now, let's say we have the complete Wikipedia data, or let's say we have the complete research paper data or the blog data. Whenever we talk about Wikipedia data, it means we have the millions and trillions of data available on the Wikipedia, right? Now, let's say if we are going to pass millions of the data to our LSTM model. Okay, so what happened here? Our LSTM, long short term memory, our LSTM model, it remember the data for some time, so that the later, whenever we want to check, okay, so whatever the data that we have passed a previous time, let's verify. Okay, so we can easily verify or we can easily check. Okay, so what happened here in a LSTM, let me write, in a LSTM model. So our LSTM model remember the data for some time, so that whenever we want to check or whenever we want to verify the previous data, easily that we can verify. So as you can see, we have the definition. As we discussed in RNN, are not able to memorize our data for long time. In RNN, that we have the issue, gradient and exploding gradient issue, where RNN can't remember the entire previous data. Okay, so RNN are not able to memorize the data for the long time and begins to forget its previous input. So whenever we are going to pass the long sentences as a corpus of the input data, it's after some time it is able to forget our entire data, our RNN. That's why to overcome this particular issue, we have the vanishing gradient and exploding gradient, we use the LSTM. So to overcome this particular issue, that is called vanishing gradient and exploding gradient issue, we use the LSTM. So this particular point clear, everyone? Why we need LSTM? Can I get yes or no?
Yes, sir.
Because RNN not able to remember our data. That's why we need a LSTM, long short term memory. Now, here they are used as a solution for short-term memory learning. Also, RNN, when the new information is added, RNN completely modify the existing information. So when we add the new information, let's say if I'm going to write HEY, hey, in my WhatsApp. Okay, so when we search H, when we write H, we are getting some different suggestion. When we add next word, that is called E, we are getting some different suggestion. Now, if I'm going to write L, we will get the different suggestion, and when we are going to write Y, we will get the different suggestion. So same thing here that we have. Whenever we are going to add the new information in a RNN completely modify the entire existing suggestion or the existing information. So RNN is not able to distinguish between the important or not important information for our suggestions. Okay, so whereas in the LSTM, there are a small modification in existing information when a new information is added, because LSTM contains the gate which determine the flow of the data, flow of instruction of the data. So what happened in a LSTM, when we pass the data, this is the, let's say this is the RNN block that we have, we are going to pass H, we are getting some output here, same output that we are sending here as a input, and then we are sending the second input. So this is the first input and this is the second input, two input that we are going to pass. Now again, if we are going to add the another input, so again the previous output that we can send as a input, and we can send our third input here, right? Now what happened in this process, we are sending all the data one by one and we are getting the final prediction. Now in LSTM, what happened in a LSTM, we have the three important gate. First is a input gate, second is a memory gate, and third is a forget gate, and one more, fourth is a output gate. Okay, so input gate, it will help us to send the data to our LSTM model. Second is a memory gate. It will help us to remember our all the input and output information. So it will help us to remember our all the information. Third is a input, output, and input memory and forget gate. So forget gate, it will help us to forget unimportant or not important words from our data set. Because let's say we are using a chat GPT. Okay, so we are using the chat GPT, and let's say if you are using a chat GPT free version, so we have some token limit. So let's say we have the token limit is 8,000. So if you cross the 8,000, you can't use the chat GPT in a same day. After 24 hour, or I thought after 6 hour. After 6 hour that we can use the chat GPT. Okay, so same thing here that we have. So whatever the data that we are going to send to the LSTM model, let's say we are going to send I love Apple. So this is the data that we are going to send. Now what happened? First of all, that we need to convert this particular data into the word, or we can say the token. Okay, so I, first word, love, second word, and Apple is a third word. Now we can convert into numeric format. So let's say 0.0 something that we have numeric, 0.02 and 0.03. Some numeric data that we are getting here. So what happened in this particular numeric data? As we are sending I love Apple. So here I is a stop word. Okay. So what happened when we apply the forget gate? So forget gate, it will help us to remove unwanted data, or we can say the unimportant data from our complete corpus or from our complete sentences. Fourth, we have the output gate. Output gate help us to generate the output based upon the memory and based upon the input gate. Clear these 4 points? Input gate, memory gate, forget gate, and output gate. Yes.
Yes, sir.
Clear? Fine. Now, let me back to our sheet again. So here we have a complete architecture for LSTM. So as you can see here, we have some notation. So xt, it means the input vector, input gate. C t minus 1, it means the memory from the previous block. In our RNN session, in our last session, we discussed 1 point x of t minus 1. X of t minus 1. So x of t, it means current input. X of t minus 1 is a previous input. Same thing here that we have x of C of t, it means current memory. C of t minus 1, it means the previous memory, previous data. Clear? These 2 points? X of
Yes,
t and
sir.
C of t. Now here we have the H of t. It means the output from the previous block. Previous block, it means we are going to send a data multiple times, like I love Apple. So let's say this is the 3 sentence. I love Apple is a 3 sentence. Or let's say I love Apple. My name is Shivan Kumar. I am from Bangalore. So like here we have the 3 sentences. I love Apple. My name is Shivan Kumar. I am from Bangalore. So 3 sentences that we have. So we can pass one by one all the sentences to our LSTM. So when we are sending I love Apple, so I love Apple, or like Apple is good. Let's say Apple is good. So we are going to do the prediction, sentiment prediction. Okay, sentiment prediction like positive or negative. So this Apple is good. So we can say the positive sentiment. So here we will get the output positive. Now we are going to send next word. Let's say machine translation that we are doing. So my name is Shivan Kumar. So now I love Apple is a previous input and positive is a previous output. So previous output we can represent as a h of t minus 1. So output of the previous block, it means output from the previous input. So this is the simple notation that we have, like output h of t minus 1, it means the previous output. C of t minus 1, it means from the previous memory block. X of t, it means the current input. Now C of t, it means the current memory. So here C of t, it means memory from the current block. H of t, it means output from the current block. So whenever we have the t, it means current one. T minus 1, it means from the previous one. Okay. Now we have some sigmoid function here. So non-linearities like sigmoid function, tangent function, biases that we are going to add, vector operation, so element wise operation, and element wise summation on concatenation. So these are the some of the symbol, or we can say notation, that we have in this particular LSTM architecture. Now let's try to understand this particular complete architecture. But before this one, let's discuss some gate. Like in this particular architecture, we have the 4 gate, as I mentioned: forget gate, input gate, memory gate, and the output gate. So let's discuss one by one. So forget gate, this gate decide which information is important. As I mentioned, forget gate, it will help us to forget the unimportant information. Okay, so this gate decide which information is important and should be stored, and which information to forget. Okay, so unimportant information easily that we can forget with the help of forget gate. It removes the non-important information from the neuron cell. Neuron cell, it means that we are going to pass the data from one cell to another cell. As you can see, we have the multiple arrow. We are going to pass the data from one cell to another cell. Don't worry, this particular architecture, I will explain you entire thing. But right now, just try to understand some of the terms like forget gate. Okay, so this results in optimization of the performance. This gate takes two input. One is the output generated by the previous cell, that is called memory, and the other input of the current cell. So as I mentioned, we are sending a two data. First is a current input, and the second is a previous output as a input. Previous output as a input that we are sending. Now, flowing required biases and the weight. So again, biases and the weight that we have everywhere, right? And the multiplied and the sigmoid function is applied in the value. So again, like at the end that we can apply some activation function, weight for the multiplication and the biases. So same thing, whatever the thing that we have in a neural network, same thing here we have. But forget gate help us to remove the unwanted or unimportant information from our sentences. This particular point is clear, everyone? Can I get yes?
Yes, sir.
Ravi
Yes, sir.
Teja, Purnima.
Yes, sir.
Okay. Where is Ravi Teja? Ravi Teja, are you there? Yes, Jaya.
Sir, he's there, but he's attending the meeting, but he's not attending it from the house. So
Okay, okay, fine.
he can't answer you back.
Okay, okay, fine, no issue. So here as you
Yeah.
can see, like here we have notation for this particular forget gate. So as you can see, as I mentioned, let me open my pen. Understand this particular notation, because going forward, it will help you out to learn the generative AI concepts. Okay, so understand the complete notation. If you face any issue, just let me know. Let me open my pen. Yeah. So as you can see, here we have x of t. So what is this particular x of t? It's a current input. Current input. H of t, it means previous output as a input that we are sending. F of t, it means forget gate. Here we have the sigmoid activation function. So we are sending, as you can see, just focus on the arrow. Just focus on the arrow. We are sending the input data, as well as we are sending the previous output as a input along with the sigmoid function to our forget gate, so that whatever the important information that we have, our forget gate, it will take the important information and it will remove the unimportant information from our sentences. Okay, clear this notation? Yes, no?
Sir, can you repeat one more, sir?
Okay, so here, like this is the simple forget get notation that we have. So what happened in this particular notation? Here we have the x of t, it means the current input. H of t minus 1, it means the previous output as a input we are going to send to our forget gate. After that, f of t, it means the forget gate, and this particular symbol is a sigmoid function that we have. Now what we are doing here, we are sending our x of input data, x of t, it means the current input data, along with our previous output as a input that we are sending, along with our activation function that is called sigmoid activation function, to our forget gate, so that our forget gate find out the important information and unimportant information. So it will do the segregation, important and unimportant. So it will store the important information, and after that it will remove the unimportant information. Now clear?
Yes, sir.
Clear?
Yes,
Here
sir.
you can see the symbol forget gate decide which information is important and should be stored and which information to forget. It removes the non-important information from the neuron cell, and this result is in the optimization of performance. So this particular result, it will help us to do the optimization. So as I mentioned, a chat GPT example, So let's say if I know, okay, so I just need to create the JD. I just need to create the interview question based upon the JD, So I just write the prompt, okay, so help me to create the 5 interview question or 10 interview question based upon the JD. Let's say if I'm going to write, okay, just create the interview question based upon the JD. So it might be possible we will get 5 question, 10 question, 20 question or 50 questions, right? So as we have the token limit here, so it will be good that we can set, okay, so I just need 5 question or 10 question or 20 question or 30 question. Okay, in this case that we can save the token. And in a real time scenario, what happened, as we use millions and trillions of the data to train the model. So if we are using millions of the data, definitely we have some cost, we have some GPU cost, right? So to save those particular GPU cost, we remove the unimportant features from our sentences. Now clear? Forget gate? Yes?
Yes, sir.
Yes, sir. But
Okay.
sir, what is the use of an activation function?
Activation function here that we are using, so that whatever the unimportant point that we have, okay, unimportant point, it means let's say that we have one of the data, okay, and from the data, like let's say we have the data like I love apple, I love apple. So whatever the important word that we have, like let's say I is a stop word here, right? Apart from the I, we have here love and we have the apple, love and apple. So we can keep these two words only. Okay, so this particular mainly activation function, it will help us to activate or deactivate the neurons. Neurons, it means our data. So okay, this particular I is not important, so we can deactivate this particular neuron. As this is the important word, so we can activate and we can send it to our next neuron where we can do the multiplication with the weight. So activation function, it will help us to activate or deactivate the neurons. Clear?
Yes, sir.
Sir, unimportant words are stop words, right? How?
Not only a stop word. So let's say like we are building some types of the application like chatbot. Okay, chatbot. And in a chatbot, what happened? Let's say if like we are interacting with one of the chatbot, and I mentioned, okay, so help me with the weather of today, like from the Bangalore or anywhere. Okay, now here I just like as a input, as a human person that we can understand. Okay, so the person asking for weather and in a particular location. But when we write the English sentence, like we can write like this one. Okay, so tell me the weather of today in Bangalore. So tell me, just count. Tell me the weather. Only weather is important of
Yes, sir.
today in Bangalore. So here we have only 3 important words. But if we are writing the sentences, we have the total 9 words. So this
Okay.
particular 6 unimportant word that we can remove.
Okay, okay, sir.
Okay, clear,
Okay, sir.
Jaya?
Yes, sir.
Okay, fine. Now, next gate that we have here is the input gate. So input gate is simple that we are sending the data. Okay. So this gate is used to add the information to the neuron cell. Add the new information one by one information to our neural cell. It is responsible of what value should be added to cell by using the activation function like sigmoid. Okay. So which information that we can add via the input to our activation function using the sigmoid activation function. That's why we have here the sigmoid activation function. So it creates an array of the information that has to be added. This is done by using the another activation function that is called tanh activation function. So in this particular complete layer, as you can see here, we have the sigmoid activation function, and here we have the tanh activation function. Okay, so first time, whatever the data that we can send, it will go to our sigmoid activation function, and when we send the data second time, it might be possible we can send to like sigmoid, as well as we can send to our tanh. As you can see the arrow, just see the arrow, sigmoid plus tanh activation function. So we are sending to both the activation function, same thing that we have here. Okay, so this is done by using the another activation function that is called tanh, and it generates the value between -1 and 1. So the sigmoid activation function act as a filter and regulate what information has to be added in the cell. So as I mentioned, I love apple. So here we can activate the data or we can deactivate the data. Data, it means I'm talking about the neuron. So we can activate the neuron or we can deactivate the neuron. Same thing here that we have. So the sigmoid function act as a filter and regulate what information has to added in the cell. So let's say if we are going to ignore, if we are going to deactivate I from I love apple sentences, it means that we are going to ignore the I. And as I mentioned, we are going to add, we are going to activate love and apple. It means we are going to only add an apple to our next cell in our LSTM model. Clear? Input gate?
Yes, yes, sir.
Yes, Jaya?
Yes.
Yes, sir.
Okay, fine. Now, here you can see same thing that we have. So x of t is a current one, h of t minus 1 is a previous one, sigmoid and tanh activation function. At the end that we are getting the memory block. CT, it means the memory block. Now we have the output layer. So this gate is responsible for selecting the important information from the cell and show it as an output. It creates a vector of the value using the tanh activation function, which ranges from -1 to 1, and it is the previous output and the current output, current input, previous output and the current input as a regulator, which also includes the sigmoid function and decide which values should be shown as a output. Okay, so based upon our previous output and the current output, current input, we are getting the suggestion. So if I'm going to write H, then I'm going to write E. So whatever the suggestion that we are getting, whenever we are writing H, it might be possible we will get the same suggestion. Sometimes we are getting the different suggestion, because if we are going to change the next word that is called E, we will get the different suggestion. If you want, you can just check it out with your mobile phone. So if I open, so here, let me check. Yes, I mentioned H. I'm getting three suggestions: H, H O, and H double M. Now I'm going to add next word that is called E. Now I'm getting suggestion H E, H E double L O, H E R E. So whenever we are going to add the next data, next input plus previous output that is called H E. Okay, so we are getting the different output. So same thing that we have here. So it is the previous output and the current input as a regulator, which also includes the sigmoid function and decide which value should be shown as a output. Clear? Clear?
So can you tell again where exactly is activation function and sigmoidal function used?
Yeah, so I will explain this one in architecture. Don't worry. Now I'm going to start with the architecture. So yeah, let me open the architecture, because we need to do the calculation as well. So LSTM. LSTM architecture. I need something different. Let me open this one. Yeah, so this is visible. Please confirm once.
Yes, sir.
Yes, okay. So this is the LSTM architecture that we have. Now let's try to understand the complete architecture and the mathematical calculation here. Okay. So here, as you can see, we have the x of t, it means the current input. Current input. H of t minus 1, it means the previous output. C of t minus 1, it means the previous memory block output. Okay. H of 2, it means the current output. Current output. So these are the symbol notation that we have for everything. Now here we have the sigmoid activation function. This is a tanh activation function. F of t, it means the forget gate. Now let's understand how we can do this particular complete calculation. Okay. So here we have some terms that we have like sigmoid, like I of t. Let me write in this way. So here we are sending the data. X of t plus, we are sending a two data here, current input plus previous output as a input. So x of t into h of t minus 1. H of t minus 1. Where we are going to send this particular data? To our sigmoid activation function. So can we write like this one? This particular equation? Sigmoid of x of t plus h of t minus 1 can be write like this one, because we are going to send two data here. So that's why we are going to perform here addition operation. X of t plus h of t minus 1. Where we are going to send this particular data? So we are going to send to our sigmoid function. So can we write like this one, this particular equation? Yes, no?
Yes, sir.
Yes. So this is the IT. It means input at timestamp t. Input data at timestamp t. So this is the same equation that we have. Just forget about W and U right now. Here W is a weight that we have, but just forget about W and I. Just try to understand the simple equation first. So this is the first equation that we have, input gate. First equation, right? Now let's try to understand the second, forget gate. So here, as we are sending the input data, x of t is a input data. So what we can do, this particular input data, and this is the h of t, it means the previous output as a input that we are going to send. So can we say like this one can be assigned some weight as well? Because let's say this is the simple neuron that we have, like x1, x2 and x3. Here we have the hidden layer, and if we are sending the data to this particular hidden layer, and based upon this one we are getting some output here. So whenever we are sending this data, we have some weight here, w1, w2, w3, w4 and so on, some weight that we have. So we can say x1 into w1 plus x2 into w2 and the so on, that we can say. Same thing, whenever we are sending the data here, so we have some weight for our current data plus our previous data. So can be like this one. So weight of I, because we have the multiple bit right now, we don't know. So that's why we are going to say weight of I, and x of t, it means weight of I. Or let's assign this one is u, as we have the symbol u. So let's assign u here. Can we write like this one, this particular equation? If I simplify this one like this one, so sigmoid x of t ui plus h of t minus 1 wi. Can we write like this one? Yes or no? Got it this particular point or not? Just let me know once. If no, I will explain you again. Jaya, Purnima.
Yes, sir.
Jaya, got it?
Yes, sir.
Fine. So what we are doing, we are just adding our current input plus previous output as an input whenever we are doing the summation. So this is the summation that we are doing. So this is the first gate. Now we reach till here. Next that we have now our data present here. Now we need to assign the forget gate so that whatever the important and unimportant information that we have, we can segregate and we can pass only important information to our memory gate to get the final output. Now let's talk about this particular forget gate. So let me remove here forget gate. Now we are talking about the forget gate. So again, summation of, it means sigmoid, we are sending x of t and h of t minus 1 where? To our forget gate. So can we write the same equation, this particular equation, like this one? X of t, u of f, it means we are talking about the forget gate, I it means we are talking about the input gate, plus h of t minus 1 w of f, and this is the same equation that we have here. How? We are just introducing the forget gate here. So this is the forget gate. Nothing else. Same input data that we have, but here we are talking about the input gate. Here we are talking about the forget gate. Clear? Forget gate. You just need to understand two gate, input and memory. Based upon this one, we have the entire gates. Clear? Can I get? Yes, no? Forget gate. Jaya.
Yes, sir.
Clear? Fine.
Yes, sir. Yes.
Okay. Now next that we have the output gate here. So input gate we got it, output gate we got it, and here we have the forget gate. So now let's talk about the forget gate. So what happened in this particular forget gate? Sorry, output gate. So whatever the important, let's say here we have some data, like we are going to segregate important and unimportant. So be segregated, and whatever the important data that we have, now this particular important data that we are going to send to our memory, and then we are getting the output. This particular important data only, not a unimportant data. So we can write an equation like this one. OT, it means we are talking about the output gate. Again, we have the summation, same summation. So sigmoid of x of t into UO. We are talking about the output gate right now. That's why we are going to assign O here. Plus h of t minus 1 WO. Same equation. We are just changing the gate only. Input to forget to output. Everything is same. Clear? Output gate?
Yes, sir.
Yes? Fine.
Yes, sir.
Now, next that we have here the memory gate. Next that we have here is a memory gate. Next we have the memory gate. Memory, this is the memory gate and this is the previous memory gate. So that's why we have the slash here. Okay, C of t. So that's why we have the previous memory gate that we are talking about. Okay, so here, whenever we are talking about the previous memory, it means whatever the output that we have generated here, same output that we have stored here in a CT, in a memory gate. C of t, it means memory gate. So whatever the output that we have generated, same output that we have saved here to remember for the future usage, right? So what we are going to do, now this particular output C of t, we are going to call here a C of t minus 1. It means this is the previous output, because here I am going to send the another data that is called x2. This particular output is for x1, input 1. Now we are going to send x2. Again, that we are sending the previous output as a input. Again, we are going to apply the forget gate. Again, we will get some output. It means whatever the previous output that we have, we are going to store as a previous memory, so that later part, whenever we need, we can use this particular memory, we can use this particular data from our memory. Okay, so this is the C of t minus 1. It means the previous memory block. Now let's talk about C of t minus 1. So what happened in a C of t minus 1? Whatever the data that we are sending, a second time x2 I'm talking about, it means input to second data we are sending plus this particular st output we are sending as a input. So again that we are going to do the addition. Now this time what we are going to do, we are sending this particular data to our forget gate plus our memory gate. As you can see, memory gate via the tanh activation function. So here we have the C of t. We are going to calculate the C of t. We calculated f of t based upon these two things. Now we are going to calculate C of t. It means we need to add the tanh, not a sigmoid. Clear? Not a sigmoid. We are talking about C of t. Let me remove this one and explain you again. Now as you can see, when we calculated input I of t here, when we calculated I of t, so we are sending the data x of t plus h of t minus 1 to our sigmoid function. So here we are calling sigmoid. Now when we calculated the f of t, we are using this particular sigmoid data. Now we are going to calculate C of t slash C of t. So do we have any connection between the forget gate and C of t, guys? Can you please confirm? Do we have any connection? Do we have any arrow connection in between the f of t and C of t? No, right? Because till here we have this particular C of t, right? So we did not have any types of the connection. It means we need to send the data from here via the tanh or via this particular sigmoid, right? Via this particular sigmoid or via this particular tanh. But we need to calculate the tanh. If I create the graph like this one, so let's say I'm traveling. Okay, so okay, let me share like stop sharing. Let me share my another screen because I did not want to remove this particular all the writing. So let me share my another screen. Yes, can you please confirm? Is my another screen visible?
Yes,
Yes,
sir.
sir.
Yes. Now let's say right now we are in Bangalore. Right now, Bangalore. Now let's say if I want to travel like Delhi, I want to travel by the train. So in between, like let's say we have like Chennai, or let's say Chennai plus Pune, like because whenever we are traveling via the train, okay, so train goes from Chennai, Pune, Maharashtra, and so on, Delhi. Okay, so let's say Chennai, Pune. Okay, before Pune, we can write here MP, Madhya Pradesh, Pune. Okay, now another, let's say another route, we need to reach here. Okay, now let's say if we have the another route, let's say via the Hyderabad. Let's assume via the Hyderabad. Okay, we want to reach Delhi. But I need to pick up something from this particular point, from this particular MP. So we need to go via the Chennai MP, then we can pick up our like whatever the thing that we have here. Let's say if I'm going via the Hyderabad, in this case we can't pick up, right? So we need to go via this particular thing. So that's why here we have our notation. If I show you again, so as you can see in this particular notation, we need to go via the tanh. Because this particular C of t, we need to calculate the C of t. So we need to go via this particular tanh, then we can calculate this particular C of t. If I need to pick up my whatever the things that I have in MP, I need to go via the Chennai MP and then I can pick up my product. If I'm going via the Hyderabad, I can't pick up my product. So we can't go in this particular direction. We need to go via the tanh activation function. So same thing here that we have in C of t. So C slash t equal to tanh input data x of t, input x of t plus h of t minus 1. So x of t, h of t minus 1. Again, this is the weight that we have. Weight for this particular location and U for this particular location. Got it? This particular C of t minus 1. Why we are going via this particular like this particular tan h? Why not via the sigmoid?
Yes,
Got it or
sir.
not? Got it, right? Because we need to calculate C of t. Our main aim to calculate the C of t, not to reach Delhi. I need to pick up my product. This is my main goal. That's why I need to go via the Chennai, then MP, then I can pick up my product. If I'm going via this particular location, in this case, we can't calculate C of t. That's why we are using the tan h activation function. So this is the equation that we have. Clear this 4 equation, x of t, f of t, o of t, and c slash t. This 4 equation is clear, everyone?
Yes,
Yes,
sir.
sir.
Yes, fine.
Yes.
Now, next that we have here, C of t. It means the memory block. C of t, it means the memory block. This one that we are going to calculate. This one. So this one that we can calculate with the help of forget get, plus as you can see, let's say first time I am going to send the data. So do we have any h of t minus 1? Do we have any h of t minus 1 as we are going to send first time data? Do we have any h of t minus 1? Can I get yes or no?
Yes, sir.
How? We are going to send data first time. So we did not have any previous output, right?
Yes.
Previous h of t, it means the previous output. It means this is 0. Now same thing as we are going to send first time our input data. So we did not have anything in our memory block, in our C of t minus 1. It means this one we can say 0. We can say C of t minus 1. Now let's calculate C of t. That is called this one. So we are sending a data via the forget gate. So here we have the forget gate. We are going to use the entire forget gate. So forget gate into C of t minus 1. So you can see this is the forget gate. So here we have the two location. C of t and f of t. We are going to do the multiplication here. So f of t into C of t minus 1 plus input data, this particular input into C of t minus 1. Which one? This one, because we have the two root. To reach here, to reach C of t minus 1, we have the two root. First one is via f of t, second one via C of t. So we need to add both of them, then we can calculate C of t. So we are doing the calculation f of t into C of t minus 1 plus x of t, it means the current input, into C of t minus 1. Then we are getting the final memory block. Clear this one? Yes,
Can
no?
you explain it again, sir?
Okay, fine. Now we are going to calculate here. We are going to calculate C of t minus 1. C of t minus 1. So let's say that we are going to calculate first time. Let's say we are going to calculate C of t first time. So let's say if we are sending a data first time to our LSTM cell first time, it means h of t minus 1 is 0. If we are sending a data first time, it means h of t minus 1 is 0. Again, same C of t minus 1 is 0 because this is the memory block. And as we are learning first time LSTM. So before this one, before the today class, I can say your LSTM knowledge is 0. So we can say C of t minus 1 is 0 because this is the memory block. And before the today's session, you don't know anything LSTM. So that's why we are going to say your memory, your knowledge regarding the LSTM is 0. Now, as we need to find out your current knowledge related to LSTM after learning this particular class. So how we can calculate? Based upon the class, based upon this particular discussion of this particular class, we can say your understanding is 80%, 90%, and 100%. Same thing here we are going to do. So to understand this particular LSTM session, you have the two way. First one, You can watch any types of the recordings from the YouTube, or you can join any types of the training institute. Else you can join here the live session. Same thing here that we have to calculate the memory block, that is called C of T. We have the two route. First one via the sigmoid function, via the sigmoid and forget gate. Second, via the tan H and C of T. We have the two gate, just see the arrow. Just see the arrow. We have the two gate, right? Final that we are getting. So two arrow that we have, it means two path that we have to calculate the C of T. So as we have the two path, what we need to do? We need to sum up both the path. We need to sum up both the path to calculate the final memory. Now, how? Let me show you. So here, as you can see, as we are sending the data first time, as we are sending a data, so we can send the data via the forget gate or via the tan H. So let's assume as we have the forget gate, as we have already calculated the forget gate here. So what we are going to do? We are going to multiply this particular forget gate with our C of T minus 1. It means the previous memory, that is called 0. So we are going to multiply with this one. This one, we are going to do the multiplication first. So f of t into C of T minus 1, it means the forget gate into previous memory plus as I mentioned, we can sum up both the path. So plus input from the current data, current input into C of T. C of T, it means this one, this particular thing, C of T. Current input plus previous C of T, and then we are getting the final current memory block. Now got it, Jaya?
Yes, sir.
Yes, Purnima?
Yes, sir.
Okay, fine. Now after that, one more thing that we have to calculate h of t. To calculate h of t here, so as you can see, h of t that we have on the two places, h of t and h of t. So to calculate the h of t, again we have the two path. Again we have the two path. First one via this one. So we already calculated this particular C of t, like via the f of t and C of t. So we already have the C of t. So this one that we can use. Else second that we have this particular path. This particular part to get the tan H. Via the tan H, we can calculate h of t. So what we are going to do? We are calculating the h of t, that is called the final output, equal to tan H, this particular tan H activation function that we are using. C of t, it means this one, the previous output. It means the memory block that we are using. C of t into output, OT, this particular output that we are using. Clear? So you just need to understand first, second, and third. Only three things. Based upon this one, we have the entire calculation. Clear now? Yes, Jaya?
Yes,
Yes,
sir.
sir.
Okay. So this is the entire LSTM calculation that we have. So we just need to focus on the three gate. First is the input gate, forget gate, forget gate, output gate, and the memory gate. And based upon this one, we have our entire calculation. Now, if I show you the architecture here, so let me open. So here we have the complete visual multiplication. So here, as you can see, we are sending the input data. We have the previous hidden state, h of t minus 1. So just focus on here. So concatenation, we are getting the forget gate. We are doing the multiplication with the previous C of t minus 1. Now again forget gate, multiplication. We are doing the addition. Then we are getting the C of t minus 1. So two multiplication and one addition that we are getting, and then we are getting the final output. So if I show you again, so as you can see, just focus on here. Just focus on this particular visualization once. Let me rerun again. Just focus how this particular works. Just focus on here. Let me rerun again once. Yes, now it will start again. So input gate, concatenation that we are doing, forget gate, multiplication with C of t minus 1, again input gate, multiplication, addition, then memory gate, then again output gate, we are getting the final h of t minus 1. H of t. Okay, same thing that we have here. Same thing that we have here. So we are sending the data, we are concatenating this one, we are going to do the multiplication with forget gate and memory gate. We are adding here, so adding this one plus this one, and then we are getting C of t, and after that, after doing the multiplication with this one, we are getting the final output. So see here, same thing, concatenation, forget, multiplication, again another input gate, multiplication, then addition, then memory gate, then again output gate, multiplication, and then final output gate. Clear now?
Yes, sir.
Yes.
Yes.
Yeah.
Yes.
So this is our complete LSTM. Okay. So in this way, our complete LSTM works. Now, this is the simple LSTM. This is a simple LSTM. One type that we have, like we have the multiple type, but this is fine. Like based upon this particular architecture, that we will get the idea. So let me explain one more point. So here, this is the one LSTM that we have. Now what happened? One more type that we have here, stacked LSTM. So in a stacked LSTM, what happened? Like we have the multiple LSTM on the top of other. So first LSTM, second LSTM, third LSTM, fourth LSTM, and the so on. If I show you, so let me show you the file. Stacked LSTM. So here you can see input LSTM, again another LSTM, and then output. Again, like we can add multiple LSTM, 1, 2, 3, 4 till n we can add. So start with n, multiple LSTM in between the input and output, and then we are getting the final output. In between, internal calculation that we have, internal architecture that we have, this one under the LSTM, this particular LSTM. Okay, so as you can see the simple definition. So a stacked LSTM is a deep learning architecture that consists of the multiple layer of LSTM units, multiple layer. At the end, we have the same calculation. Now, in a traditional LSTM, there is a single layer of LSTM units that process the input sequence. In contrast, the stacked LSTM consists of the multiple layer, one top of other, as I mentioned. How this works? So the output from each layer is passed the input to the next layer. It means after pre-processing from here, that becomes sent to the next layer, and next layer, and then we are getting the final output. So this is the stacked LSTM, one top of other. Clear this one? One top of other. At the end, we have the same calculation, same architecture. Internal architecture is same. Clear? Jaya Punima.
Yes, sir.
Okay.
Yes. Yes.
Fine.
Sir.
So this is all about LSTM. Okay. I'm going to share this particular notebook. Make sure you can just go through it. Okay. And next session that we can discuss the encoder decoder. And after that, we can jump into the generative AI concepts after 1 or 2 session. Okay. So just go through this particular notebook, because based upon this particular discussion, we can discuss the next topic that is called encoder decoder. So now all the topics are interconnected. RNN depends, like LSTM depends on RNN depends on neural network, and encoder decoder depends on our LSTM and RNN. Okay, so make sure go through the file and let me know if you face any issue. Okay, fine, everyone.
Yes,
Yes.
sir.
Sure.
Okay, fine. So just go through it and let me know if you face any issue. Next session that we can discuss encoder decoder. Okay.
Okay, sir.
Yeah, fine.
Yes, sir.
So let's conclude here and see you again on our upcoming session. Okay, we can continue.
Thank you, sir.
Yes,
Yeah.
sir. Thank
Okay.
you, sir.
Okay. Yeah. Okay. Bye.